My name is V. Dinesh, and the topic is energy level diagram of P-type semiconductors, and subject is applied physics. Energy level diagram of P-type semiconductors. What is a P-type semiconductor? A crystal that has its conduction value in between conductor and insulator is termed as the semiconductor. It can be formed by the addition of impurities. It can be referred to as either P-type or N-type. Hence, its conduction is based on the types and the amount of impurity added. These solids' conduction value is proportional to a temperature value. As the temperature increases, its conduction value increases. As temperature decreases, then the conduction of the semiconductor tends to decrease. What is a p-type semiconductor? If if the intrinsic semiconductor is doped with an electron acceptor in order to make it as a p-type semiconductor, the electron acceptor is responsible for the formation of a hole by accepting an electron from the lattice. As a result, majority carriers in the p-type semiconductor form the holes. In this way, a p-type semiconductor is defined based on its electron acceptor capability. Formation of p-type semiconductor. In order to form p-type semiconductor, the basic step is to dope intrinsic semiconductor with trivalent impurity. In this type, the valence shell consists of three electrons requires further one more electron. This is possible by sharing the electron. As it is accepting electrons, it is generally referred to as acceptor. The acceptor impurities are boron, indium, gallium. Once these are added to either silicon or germanium, p-type semiconductors are formed. Let us take boron as the trivalent impurity so that we can add it to the silicon in order to make it extrinsic. Everything here is completely based on the concept of sharing. The covalent bond concept is preferred during accepting the electrons. Boron atomic number is 5. Based on its valence shell electron configuration, concept the numbers of valence electrons present in boron are 3. Hence, each valence electron forms a covalent bond with the neighboring silicon atoms. The number of bonds formed with a number of silicon atoms is based on number of valence electrons present. It is evident that to boron there are four neighboring silicon atoms as per that there must be four electrons, but there are only three valence electrons present. Then the absence of fourth electron or the vacancy of the electron is termed as a hole. Example of p-type semiconductor. Trivalent impurities such as boron or gallium are commonly used in silicon as doping impurity. Whether silicon is doped with gallium or indium, the process also can be represented by utilizing the same concept of boron and silicon. Silicon doped with boron as shown in the figure. In this way, the semiconductors that are rich in holes as their carriers found by the trivalent impurities comes under the list of p-type semiconductors. Energy diagram of p-type semiconductor. As it is doped with trivalent impurity, there are huge number of holes formed in the p-type. Hence, it has majority concentration of holes and minority concentration of electrons in it. P-type, because of majority holes, it is referred to as a positive type. As it is a p-type semiconductor, the Fermi level is present near to valence band rather than conduction band. Energy band diagram of p-type semiconductor as shown in the figure. Once the impurity is inserted in the pure semiconductor, nu- numerous amounts of holes are formed in the valence bond. There are thermal excitations also in the semiconductors. Because of the same amount of electrons are also present in the conduction band. As always, majority wins. More amount of hole compared to electrons makes p-types majority carriers as holes. As the energy band diagram suggests, there is less number of electrons in conduction band in p-type compared to that of n-type, making the state of conductivity of n-type double than that of p-type. The reason behind this is the excitations will. release a tremendous amount of energy and also enhances the flow of current, making to mold it purposefully based on requirements. That's it. Thank you, everyone.